some conditions. So g of x is a positive derivative. So first of all, this is on page 276. The function is denoted by g of x. It's not important, but anyway, has a positive derivative over. So this is how I write it. F, I just wrote g, right? So g prime of x is positive over negative infinity 0. I need to delete this, white it out. Okay, so it says on negative infinity 0 union 3 infinity. That's the first part. And the negative derivative, so g prime of x less than 0 over or on 0, 3, but neither g prime of 0 nor g prime of 3 exist. Okay, so g prime of 0 and g prime of 3 do not exist. Perfect pick. Thank you so much. I love it. Okay. So first of all, what I always say about this problem, when I look at it, this is gibberish. It doesn't make any sense to me. I can't read this. With a little bit of effort, just a tiny bit of effort, I will be able to. By summarizing all my information in the table, as we dealt with since last week. So I see 0 and 3. So 0 and 3. I see negative infinity and infinity. And I am told that the first derivative is positive between negative infinity and 0. Awesome. And it's positive between 3 and infinity. Don't cross out anything. That is in my table now. I don't care about it anymore. Then it says that this first derivative is less than 0 on the interval 0 to 3. Done. Don't cross it out. I'm just trying to make a point. Now I'm told that g prime of 0 does not exist. I don't have a number to put in there. And I'm also told that g prime of 3 does not exist. Now, and this is done. So I summarized all my information in the table. I have to caution you. I may come up with an example of a graph or a function that fulfills all the conditions that are given to us, and you may come up with a totally different one. It's okay. We are asked to graph an example. In other words, there are infinitely many correct answers. So in my situation, I'm going to say, of course, the function is increasing and decreasing. The derivative can be undefined. I'm going to put here 2 because that's what I want. As long as all the other conditions that are given in the problem are clear, are put into the problem, I'm fine. I can add on at whatever I want. It doesn't matter. Okay, so this is for me, of course, and for everybody, a relative max or local max. I'm going to say here 1 or whatever. It doesn't matter, right? And the function is increasing. So my 3, 1 is a relative or local min. That's all I need. But remember, if the derivative is undefined, the function has to have maybe a cusp or maybe a corner, because it's telling us at these points the derivative does not exist. At this point, the derivative does not exist, although the function is continuous. The same here. Okay, so here's my example. Good. So let's see. It's increasing to 0, 2. I have to make it a cusp or a corner. It's up to you. You can make it a cusp or a corner. Then it's decreasing to 3, 1. You can make it a cusp or a corner. And then increasing. This is an example, and there are infinitely many. So this is my example of g of x. So what is the trick here? What have we learned from here? This is gibberish till I put it in the table. That makes no sense to me. While the moment I have it in the table and I realize what is happening here, this is a piece of cake. If I don't summarize the information in the table, I will not know what to do. That's why we study this table.
I have a question real quick.
Yes?
You made it a cusp or a corner because it says the g prime of 0 and 3 do not exist.
Exactly.
Okay.
Is this okay, everyone? Any questions on this? Is this okay? Naja, you feel better about this?
Yes, thank you so much.
Thank you. Thank you for asking, and that was the first thought I had to do today. Okay. So in section 3.2 now, we are talking about basically about the second derivative. And no, don't get scared. Derivative. When I talk and write at the same time. Don't get scared. We're not going to go beyond the second derivative. That's it. So refreshing your memory, f prime of x gives us increasing and decreasing intervals and gives us max min. Okay, what about the second derivative? What will the second derivative give? Also two different things. Something called concavity. See, I talk and I write. So concavity, what does it mean? Holds water? It does not hold water. Concave upward, of course, and concave downward. Okay. What is the second thing that it gives? Inflection. Point or points. Like this one was giving us max min, this one gives us inflection point. What is an inflection point? Opening downward, opening upward. This is an IP, inflection point. And of course the other way around. Upward, downward, in the sense that it's concave upward, downward. This is another IP. Same with this first derivative. The second derivative has to be at these points. The second derivative has to be 0 or the second derivative undefined. Exactly what we did with the critical numbers, but we are talking about something else now. They're not critical numbers. They are inflection points. And of course, the second derivative has to change sign. Okay? So concavity, which means opening upward, downward, and inflection points, exactly where that happens, where that change happens from upward to downward. And then we can talk a little bit about something called the second derivative test, and I'll explain in a minute. So now I'm just going to illustrate all this. We are on page, oh, I only need, so what is it? Okay, page 290. 290. Okay, so let's take a look for a moment at these graphs. So choose one, any of these graphs. So we can discuss a little bit, and then we'll move on to problems.
The first one?
First one. So see, the function is opening up, up, opening up, opening up, opening up, opening up. Stop. It starts opening down, opening down, opening down, opening down. So it holds water, but then all of a sudden it cannot. So the inflection point appears to be 1, 2. Let's choose another. or maybe the next page. It's up to you. Anyone wants to pick?
6.
6. Holding water, holding water. Yes, 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 yes. No, 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 no. Yes, 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 yes. So this is the inflection point, and this is the inflection point. Holds water? It does not. Holds water. So concave upward, concave upward, concave downward. So this is what we're going to illustrate in the next steps here. Now we are going to be able to sketch a graph. In 3.1, no. We do not have enough information for that. Okay, so let's choose a problem. Allow me to choose first, and then you choose the next problem. I would like to choose 13, this 13 here. And then you can choose the next. Rational functions are good, but they are in the next section. So let's not worry about the rational functions right now because we're going to talk about them in 3.3. So we can look at polynomials, and we can look at exponentials and log. So all these are polynomials except these.
We do 13.
Yes, so we're going to start with 13. And then you can choose the next one. So 13 has h of x equals x to the third minus 27x. So the question here is, what are we asked to do? And the answer is everything. What does that mean? Increasing, decreasing, finding max, min, establishing concavity, finding inflection points, study the sign of the derivative, first one, study the sign of the second derivative, critical numbers, inflection points, just everything, starting with the domain, of course. So I'll start my table, and of course, plus graph. Once I fill out my table, I have the graph. If I don't summarize everything in a table, I will just simply copy a graph from the graphing calculator without understanding what I'm doing. Okay, what is it? H of x, h prime always first, h of x in the middle, and the second derivative last. First, I have to establish the domain. Can anyone give us the domain of this function so we can, I have to start with that always. What is the domain of this function? Oh, of course, it's polynomial. Great job. Good. Now, because we're talking about the function, I should always plug in 0. And in this case, it's 0. Okay? I will also find the x and y intercepts. So first I discuss the function a little bit. I think we lost someone. I hope they come back. So first I have to discuss the function a little bit before I look at the first derivative and the second derivative. So obviously this is the x and y intercept. It may cross again the function. We'll find the x-intercepts in a minute. We are not, since we are in calculus, we're just going to plug it in the graphing calculator. It will give us the solutions in a minute. But also I need to find these limits. And I know how to find the limit. So limit as x approaches negative infinity from, oops, what is going on with this? It's gone. X to the third minus 27x. And then I have to find the limit as x approaches infinity from x to the third minus 27x. So when we are talking about infinity, what did we say? Which piece is the strongest? Only when we talk about infinities. Which of these two, because it only has 2 terms, I would have asked you if it had 5 terms, I would have asked you which of them is the most powerful at infinity or negative infinity.
Say x cubed.
Correct. So Where does x cubed go when x approaches negative infinity? And I will write the answer here.
Negative infinity.
Absolutely. Very good. Awesome. Excellent. Same thing here. Where is x cubed going when x approaches infinity?
Positive infinity.
That's it. That's how we determine the limits. Okay, one last thing. I want to plug this function in the graphing calculator and find all x-intercepts. How many can it have maximum? How many x-intercepts can it have?
Maybe 3.
Yes, it cannot have more than 3. Max 3 x-intercepts. Because the degree is 3. Awesome. Thank you, Tess. Okay, so I'm sharing my screen. Where are you guys? Okay, good. So again, we are doing that thing with the apps, and we want number 9. And careful now, because the degree, they call it order, is 3. Careful now how we plug in these coefficients. The coefficient of x cubed, it's correct. The coefficient of x squared is 0, because there is no x squared. The coefficient of x is negative 27. And the last coefficient is also 0, because there is no free term. So now I want to get the solutions. We already knew that x cubed, that one of the solutions was 0. We already identified that. One is 5.2 and the other one is negative 5.2. I go back immediately to my table with 5.2 and negative 5.2 and put the 0 for the function, and the 5.2 and put the 0 for the function. There is nothing else I can find about the function from the function itself. X and y intercepts and limits. Done. There is nothing else.